Hello everyone, welcome back to EG Embedded Software. In this video, I will explain the UART bootloader code overview in Kill IDE based on a new microcontrollers. We will understand why macros are used, how UART communication works, how firmware is received and written into the flash, and how MCU jump to the new application. Let's start. First, look at the header files. We are using standard.c libraries .h, string.h, standard library.h, and new micro specific drivers, new micro.h for MCU register, UART.h for UART communication, FMC.h for flash memory controller. These headers are required to implement the bootloader functionality. Now let's understand the importance macro. As defined buffer size 2048. This defines the UART receive buffer size. A larger buffer prevent data overflow during UART communication. Has defined timeout. This macro define how long the bootloader will wait for UART data. It's prevent the MCU from getting stuck if communication fail. Has defined firmware start address. This is the most important macro. It's define the flash address where the application firmware start. Now let's check the global variable. UART RX buffer store UART command response, UART RX index, track receive data position, bin start is flag set indication firmware, bin data store the firmware data for byte chunks, and write address track the current flash write address. These variable control the bootloader execution flow. Now let's move to the system initialization function. In this function, the internal high speed RC clock is enabled, UART 0 module clock is enabled, PB12, PB13 pin are used configure as a UART RX and UART TX. This this prepares the hardware for UART communication. UART initialization, UART 0 module is reset. UART 0 is open at LN5200 baud rate. This baud rate provides a good balance between speed and reliability. Main function, first protected register are unlocked. System and UART are initialization. Flash memory controller is enabled using FMC open. Then the bootloader send a message to PC like device. This tells the PC side tools that the device is ready. Next, the bootloader wait for OK response from the PC. If the response is received, bin start flag is set. Firmware reception start. UART wait for response. Receive UART data by byte. Store it in UART RX buffer. Search for the expected response using str string. A timeout mechanism ensure the MCU does not wait forever. Receive binary data. This function. Flash write address is set to 5000. Flash pages are erased starting from this address. Then firmware data is received via UART. Data is collected 4 byte at a time. Every 4 byte are implemented written into the flash. This avoids strong the full firmware in RAM and save memory. The process continue until the expected firmware size is reached. This is the last address of the application file. Write to flash. Flash update mode is enabled. Data is written into 32-bit words using FMC write. this function. Remaining bytes are handled safely. Flash update mode is disabled after update. This ensures the safe and controlled flash map programming. Handle firmware update is called. A message is printed on UART. Firmware update complete. Now comes to the final step. Restart the new firmware. Vector table address is set to 5000. This tells the MCU start execution from the new firmware. System reset the MCU. After reset the new application firmware start running. So this was the complete UART bootloader code explanation in Kill IDE. If this video helped you, please like, subscribe and share. In the next video, I will show the PC side firmware update tool and live demo. Thanks for watching.